Okay, on this one here, we're trying to look at what the acceleration of the cart's going to be based on this situation here. So we have a cart that is being pulled at 30 newtons in this direction. So that's going to be my force on it. This would be kind of considered a tensional force because you are creating tension when you pull on it. Same situation down here. Only difference is going to be between a 60-degree angle and a 30-degree angle when we're pulling in this direction. I did make the forces the same on both of them, so it's kind of easier to see. Now what I have to do is kind of figure out my force on this part here, because that's going to be where I determine if it's going to be speeding up or slowing down as far as my acceleration. Again, I got to do it like this. I can't do it like this. So on this one here, what I would do is I actually put a little angle thing here, because we've got to deal with right angles on this, and I would do the same thing here. So now I have my right angle and I can use some trigonometry. Okay, so let's say I want to figure out the forces. Let's try this one first. Okay, my newtons that are being pulled are right here. That is considered my hypotenuse. Now I'm going to be dealing with the opposite of this angle. So this one's going to be opposite hypotenuse. What is an opposite hypotenuse? Well, if you remember, it's SO, CA, TOA. And we're not dealing with this one. So with my SO, it's going to be a sine, and my angle is going to be 60 degrees, and then opposite over hypotenuse. So here's my opposite over my hypotenuse. Actually, the 30 goes down here. So it's going to be my opposite, and I'm figuring out the force that's going to be here. Again, I don't really have to do that, but I kind of like getting into a routine of doing this. So basically what I do is I just hit sine 60 and get my number, which will be 0.866 times 30. And it will tell me that my force here is going to be 25.98 newtons in an up direction. I'm not really interested in that. I want to take care of this part here. So what would I do with this one? Well, in order to figure out this one, now I'm going to deal with the adjacent one. So it's going to be cosine 60 adjacent over hypotenuse. Again, just using some kind of simple trigonometry. So what would I do? I just hit cosine 60, then I multiply it times 30, and I'll end up with 15 newtons. Let's check it and make sure that it's correct. Plus 225, that's 900. It is correct. So I was doing the Pythagorean theorem, which would be, 25.98 squared plus 15 squared equals 30 squared. So now we're going to be using that too. So that's how it works on this one here. Now I've got this, I've got this. We're kind of pulling on it a whole lot. The acceleration's actually going to be pretty high with this. So it's going to be a high acceleration because I have a lot higher force going on the other one. Now let's go ahead and work on this one and figure out what the force is going to be on this one. So we're going to do the same procedures as what we did up here. Now we're going to have a sine 30. and I'm still going to be doing my opposite from this angle for this one here. So it's going to be this, 30. That will tell me my opposite, because that's so. So it's going to be, I'm going to go sine 30 times 30, and I got 15 newtons here. Now I'm going to do cosine 30. And now I'm going to be dealing with the adjacent one. So I'm going to go cosine 30 times 30. And now I've got 25.98. So when I messed with the angle and made it half of what's on this one, my force actually increased a whole lot in this direction, which actually would make sense. So what happens with my acceleration in comparison? Well, on this one I have a lot more force going on this side, so what's going to happen to my acceleration? Acceleration is going to go up. On this one, in comparison, my acceleration will actually go down. So once I tweak with the angle, actually I'm going to have more of a pulling force that's going to be equal to this one. This one I have less of a pulling force because I have a really high angle. Again, you can do trigonometry, or you can really just do common sense. The lower the angle on the pull is going to cause your acceleration to go down. The higher the angle with the same pull, the acceleration is going to go up.